Okay. So this is section 3 in your book. Now it's actually based on perfect squares. I'll make it a bit smaller. Yeah, so it's based on perfect squares. We'll go through these two diagrams first. The second one is missing the work from the textbook. I'm not sure why, but anyway, we'll go through it, and this will help you understand in another way how you can do this. Now, normally, a plus b all squared, we know this by expansion, right? So we can expand it. A plus b times a plus b is a squared plus ab, okay, ab plus ab plus b squared. And we can see it's a squared plus 2ab plus b squared. We've learned this already, haven't we? Okay, so we're going to just look at the diagram method for doing these problems. So yeah, that can just be gotten by expansion, but we can think about the area. We can think about the area of this square here. So if we look at this diagram here, we've got A and B. So we know the total length is A plus B, yes? Here, that's the total length, A plus B. Just add the two lengths. And this obviously is the same. A plus B on this side. So if we multiply them, we'll get the area of the square. And it's a square because they're both A plus B. So whatever A and B are, we'll have a square. So this square is the sum of these smaller squares. So you've got this square here. I'll make it yellow. And then you've got two rectangles here, this one and this one. And you've got a small square here. So the area of the yellow square would be A times A, which is A squared. This rectangle is A times B. So AB. This blue rectangle is also A times B, AB. And the green square is B times B, so that's B squared. So if we add those numbers, we're going to have A squared, which is the yellow one here. And then we have two blue rectangles, which are AB, AB. So AB plus AB is 2AB. That's this one here. And the green square is B squared. Okay, so you can see these are actually equal just by using a diagrammatic method here, or that one there. So we're just thinking about areas of the pieces. So, but obviously you can get that by expansion as well, which we just did. In this diagram here, they set it up a little bit differently because we want to have A minus B squared. Okay, so what they did here, they put the total length as A, and this total length is also A. Yeah, let's put that there. A here, because we know that because B plus A minus B will be A, correct? Because the B will cancel. So if we add these two lengths, we'll get A. So this total square is A squared. That's this here, this one here, total area the total area of the whole square, the big square, including the rectangles and the small square. So we want an expression for a minus b squared. Well, let's look at these areas. So this yellow one here, the area of this square must be a minus b squared, yes? A minus b times a minus b is a minus b all squared. That's the area of the yellow square. Then we have these two blue ones. So this would be b times a minus b. Yeah, this is a minus b. This is b, so that's the area of this rectangle. This one is the same, b times a minus b. Okay, and they're equal, so I made them the same color. And this is b times b again. We'll make that green again. So that would be b squared in here. So we want an expression for this, a minus b all squared. A minus b all squared is here. So this area would be the same as the big square, a squared minus these three here. Okay, so the big square, which is a squared, minus the blue, minus the green. So I'll put that in the brackets. So we've got b a minus b, and add this one, b a minus b, plus the green one, b squared. So that would be equal to a minus b all squared. So the big square, a squared, minus these parts. So these are cut away, and we're only left with the green part, which is a minus b all squared. So if we simplify that, we should get to our rule, which is written here. So we've got a squared minus, okay, let's expand this. We've got ab minus b squared, and this bit, plus ab minus b squared, and plus b squared. Okay, by the way, you don't have to know how to do this for the test. I'm just showing you another way to get the formula. So in this case, we can cancel the b squared, and we're left this bit here. So we've got a squared minus ab, and ab is 2ab. So let's write that as 2ab. And we have a minus b squared left here, like that. So then you've got a squared minus 2ab minus negative is plus b squared. So that's your rule there. So that's obviously a very long way, but this is using a diagrammatic way, using a diagram to get the answer. But like I said, you won't need to know how to do that for the exam, but it's just another way to think about the problem. So if you think about areas, we can do many of these problems. Okay, so as an example, so look at example 1. If you have your textbook there, and I think you all have your textbook, you won't need to copy these because they're in your book already. But my working may look a bit different than what's in the book. I'm just doing it myself, so I'm not really writing what's in the textbook. So when you do these problems, we look for some kind of pattern in the numbers. We have 3 terms. So that's a good thing to start with, 3 terms. And look at the powers. We have an x4, and this is x squared. So this is a useful pattern. This one is actually x0, isn't it? Which we don't write because x0 is 1. So we never write x0 on the end. So what we try to do is change your x4 to be powers of 2. So that must be x squared squared. So that's the first thing to do. So x4 is x squared squared. Then we look at the last term, which is 36. And 36 is the same as 6 squared, isn't it? So now we have powers of 2 here, which is what you want. So do that for your first term and your last term. And we notice that we've got a plus here. So let's think about our rule. So we write our rule down. A squared plus 2ab plus b squared. Because we want powers of 2. We can't have powers of 4. So that's why we changed to powers of 2 here to match up. So here it looks like A, in this first question, A is x squared from this one, and B is 6, the same as you did the week before last. So B is 6. So if we have this pattern, we know we can write that as A plus B all squared. I might clear that out a bit. There. So then we just basically put the numbers in. So you've got A squared. So you've got x squared squared plus, and the rule tells us to write 2. So we need to put a 2 here. And then A is x squared. B is 6. And then that will be 6 squared. So remember that from the other week. X squared here and 6 here. So then we need to check this middle term, 12x squared. It should be the same as this term here. And it looks like it is, isn't it? Because 2 times 6 is 12. And this is x squared. 6 squared is 36. X squared squared is x4. So this is all the same. So it's exactly the same. I've just made it look different. So if it's in this form, then we can write it in the perfect square form. So that would be x squared plus 6 all squared. So when you're doing your working, you should show some of your steps. So show how you got A and B. Here, get A and B here. Write out your rule. That can be step 2. And then step 3 is this last line here. And your final answer is this here. That's in factored form now. And if you want to check that, we can expand it. So if you have time and you want to be sure that your answer is correct, you expand it back. So we've got x squared plus 6 times x squared plus 6, and we multiply out. So x squared is x4. X squared times 6, 6x squared. 6 times x squared, 6x squared. 6 times 6, 36. And it looks the same, isn't it? Because this here is 12x squared plus 36 plus x4. So this is correct. So if you want to check your work, just expand your factors again. Okay, so how about example 2. So we've got A4 minus 14a squared plus 49. So first thing to do, change your first and last term to powers of 2. So you've got A squared. Remember the rule, AMN is the same as A times MN multiply. So that's very useful for doing these problems. So we've got A squared, 49 is 7 squared, like that. So do that first. That's your first step here. So then we know A, if everything's working properly, A will be A squared. And B from the formula will be 7. So you can do this first, get these A and B. Then you write your formula down, A squared, and we're using minus now, minus 2AB plus B squared. And if everything works properly, we can write that as A minus B all squared. So write your formula down, and then we put these numbers or your terms into the formula. So then we'll have a squared, which is a squared squared, which is a4, minus 2, so copy from the formula 2, a is a squared, b is 7, plus b squared, which is 7 squared. Okay, so we need to check that middle term here. So that's the one we're worried about. If this is not 14 or minus 14, then we can't write it in this form here. So a squared squared, a4. Let's just check that, a4. That's good, that's a4. Now this is 2 times 7, which is 14. So minus 14 a squared, so that's the same, that's good. And 7 squared is 49. And we know the first one and the last one are going to be correct, but this is the middle one we need to check. So this is okay, which means you can write that in the form a squared minus 7 all squared. Like that, that's power 2. And that's your final answer in green there. They're your factors. Okay, so I won't do every example because I think you can start working because this is going to go into tomorrow anyway. We'll do a couple more. What I'll do, I'll just cut out this here because I'm going to talk about this anyway. So if you look at this, we do it the same way. We've got 2 terms here, 81, A4, B4. Can we make that power 2? So we want something power 2, and we want this something power 2. That's what we're trying to do first. So 81 must be 9 squared. Whoops. No power 2 there. The square's on the outside already. So 9 squared, 81. That means that if this is A4, this must be A2. And B4, this will be B2. So 9 squared, 81. A squared squared is A4. B squared squared is B4. So this is your first part. And 100 is 10 squared. So we know now that A from the formula will be 9A squared B squared. And from B will be 10. So we tried to put them in our formula. Down here, we'll write your formula. A squared, and we have minus, so we want the minus formula, 2AB plus B squared, and that is A minus B all squared, like that. And then we put A and B that we got here into our formula. So write them in. When you get good at this, you can kind of skip steps, but for the time being, just try to write everything out. So A is 9A squared B squared, squared, because A is that there. In the formula, we have minus 2, so minus 2A, and A is 9A squared B squared. B is 10. And B squared is 10 squared, which is 100. So the key here is to check your middle term, that these are the same. That's the one that we need to check because we know the first and last one are correct already. So 2 9s are 18. 18 times 10 is 180. So you see here, yeah, minus 180, so that's correct. And we have A squared, B squared here. So A squared and B squared are there. So this is all fine. This is correct. So if it's in this form, we can write it out as 9A squared, B squared, minus 10 all squared. And that's your final answer there. And I'll put that in green, green for go, all good. So that's your final answer. All right. So if you're copying, I'll leave it there for a minute. But actually it's in your book, isn't it? So I don't really need to wait. But when I show you some questions, I'll pause it a bit. So in this one here, they make it, well, let's just cross that out because we'll do that anyway. So look at your first term, look at your last term. So you've got 144 x4. So we want power 2. So we want to turn this into something power 2. Well, 144 is 12 squared. That's one you should know in your head already. So 12 squared, 144. X4 must be x squared. 2 2s are 4. Okay, so then A is 12x squared. So we write that down. And then we do the same for 36. And 36 is 6 squared. So B will be 6. So once you know what A and B are going to be, then we write our formula out. Let's use black. So A squared, and we have plus here. So we're going to be using plus 2AB plus B squared. And we know that is A plus B all squared. So if everything's working, we can factorize. So A squared was 12x squared and squared plus 2 from the formula. A is 12x squared. B is 6. And the last number squared. So just match them up like we did way back 2 weeks ago. Should look like that. So this term is here. This term is here. And we need to check the middle term now. 144 should be this number here. And if it is, we can factorize. So 2 6s are 12. 12 12s are 144, correct? We have x squared here. X squared, correct. Okay, so everything is okay here, which means our final factors would be 12x squared, which is A, plus the last term, which is 6, all squared. And that's your answer in green there. And you can also check by expanding. In a test, you wouldn't normally have enough time to check, but for homework, you can check. Also, the photo math, if you download the app, photo math, you can take a photo of that and it will give you the factors. Okay, example 5. Now with the last class, I skipped 5 and 6. They're done the same way, but I'll go through these tomorrow a little bit more because you're not going to finish today anyway, most of you. So I'll do these ones tomorrow. Now this one's a bit tricky because it's got 6 terms. So you're going to need to group terms together. I'll show you that one tomorrow. So don't bother about that one now. But exercise 3, so you can open your book to here if you're using your textbook, or you can work in your tablet as normal. Okay, so look for the pattern. Now, if you know this is perfect squares, it's very easy to do because you know what rule you're using. But if I just tell you to factorize in the test, there's many ways you could possibly factorize this, but only one way that's probably going to work. So you just have to get used to recognizing the different kinds of factorizations that you do. And you do that with practice. So look at your first term, x4, and the last term, 64y4. So we will take both of them out and make them as powers of 2. So this is what I think you should be writing in your answers when you show me work in the homework. I'll try to give you a bit more space in the worksheet for the next one, so you got space for writing. So x squared squared is x4. So that would be A. A would be x squared, this term here. 64y4 will be 8y squared squared. So here, B will be 8y squared. Like that. So these are the terms that are most likely to work. So we write your formula. So this is step 1. So write A and B. So find out what those will be from the first and last term. Then we write your formula. So we write that out as A squared plus 2AB plus B squared is A plus B all squared. So, and we notice we have plus, so we use plus in the formula here. So now we substitute the numbers in. So sub A and B. So we'll put them in. So we've got x squared squared. Let's use black. X squared squared plus 2a, which is x squared, times b, which is 8y squared, plus 8y squared squared. And check they all match up. X squared, 8y squared, 8y squared. So we're looking all right. Now we check the middle term is correct. We must get this number here, this one here, for it to be working. So you've got 2 times 8, 16. Okay, 16 is right. X squared, y squared, x squared, y squared. So the middle term's correct. And the first term and the last term are also correct, which means we can write it in the form a plus b all squared, which will be x squared plus 8y squared all squared. So that's your final answer there. And I'll do that in green. So you can copy that one down. But I think that's the working you should be showing, at least for me, until you get used to doing this. Okay, so it's the basic rule we learned from like 2 weeks ago, except we have higher powers. We got power 4 in this case. So, but the rule is the same as previously. So you can copy that down. Now, you should be looking for common factors. And I recommend today you go up until about question, say 5. So question 2 is okay. So do this the same way. And we'll review the answers tomorrow anyway. Or so I'll do a bit more today. So question 2. So do question 2. Question 3. Now in question 3, you'll see there's a common factor. So do that first. If you don't take the common factor, you need to do it later, and that makes it a bit difficult. So find your common factor here. And your common factor here will be 16. And this will be M4. And then you will factorize that. So try that yourself for a while. That's question 3. What else? Factorization. Yeah, question 4 also. Take out the common factor. And this is as far as I got with 9b. So you can work up to about question 4 or 5, because we'll do more tomorrow anyway. And I'll talk about the harder questions tomorrow. So you can go up to about, say, question 5 if you want, but stop there. Then if you get to question 5, you're finished. All right. So do question 1 to 5. You can do them now, or 2 to 5. And then we'll review the answers, maybe a bit today, and then we'll do more tomorrow anyway, because I think it's too much for today. All right, I'll mute myself for a while, and you can work for a while on those. Okay, if we look at question 2, if you're still working, you can keep working, but if you want to watch the solution, okay, so we've got 4a6 here, and 25y8. So we want to change these to powers of 2. And the last one as well, powers of 2. To power 2, I should say. Okay, so 4a6. So if this is 2, then you must have a 2 in the bracket. 2 squared is 4. And this will be a3, because remember, these are multiplied. So 2 3s are 6, not added. So don't write 4 here. And 25 is 5 squared. Y8, this must be Y4 because 2 4s are 8. So in that case, we can see A is 2A cubed and B will be 5Y4. So that's your first step, do that. Second step, write your formula out. And note the sign is negative here. So we've got A squared minus 2AB plus B squared is A minus B all squared. Next step is put your numbers in. So put your A and B into the formula. We'll do that in red. So A is 2A cubed, but then we square that, minus 2 from the formula, 2A cubed times B, which is 5Y4, plus B squared, which is 5Y4 squared, all squared. So at this next stage, you're checking your middle term here. So we need to check this middle term is correct. So then we'll do that as step 4, I guess, checking. Check terms. So 2A cubed squared is 4A6, so this one's okay. And the last term should be correct because we did that already. Then check your middle term. 2 2s are 4, 4 5s are 20. Okay, minus 20 is correct. A cubed, Y4, A cubed, Y4. So the middle term is also correct. So everything's right. So at the next stage, you can write your answer to factors. So that means that would be equal to 2A cubed minus 5Y4 all squared. And if you like, you can expand that and check the answer. So there's quite a bit of work in there to do, but I recommend to do that so you get to understand the steps better, and especially the checking. Because if that number is not minus 20, A3Y4, you cannot do this last step. So it must be the same. That's question 2. So I'll leave. All right, well, you can come back to that. You can watch the video. I'll post the video later. We have 5 minutes, so we might do this one and stop there. So as I mentioned, this has a common factor 16. And if you don't take it out now, you need to take it out later. So, well, you should take it out later. So I recommend to factorize at the start if there is a common factor. So look there first. And then we have M4. This will be minus 2, 2 16s are 32. M2, N5. And 16 has come out, so that's gone. And you'll have N10 here as the last term. The 16 is already finished, so you don't have to do anything with the 16 now. Just leave it there. I'll write this other part out here, and we'll do this. So M4 minus 2M2 N5 plus N10. So now we do as before. We change the first term and the last term to be powers of, or power 2. So we have, that's going to have to be M squared. This will be N5 squared. So remember, we want this power 2 here for the first and last term. So do that. And then we know A and B now. So A is M squared, B is N5. So write your formula. We'll do it quickly. A squared minus 2AB plus B squared So we've got m squared squared here, minus 2a, which is m squared, b, which is n5, and n5 squared, like that. And check our middle term, which should be this one here. They should be the same, and looks like they are, aren't they? So 2m2 n5, 2m2 n5. So this is all right. This is all finished. So then we can write our final factors as m2 minus n5 power 2. But remember, we had a 16 in front of that. So you need to put 16 in front here. So don't forget the original factor. m2 minus n5 all squared. So that would be your final answer there as the final. Okay, so you can copy that if you like. I'll just move it up a bit. There's only a couple of minutes left. If you want, you can do question 4 and then stop there. Okay, and then we'll talk about the answers tomorrow. So just copy that solution there if you haven't done it yet.